Hello everyone, today we're going to be covering an SBOM tool called Jake. This was made by Sonatype and is a Python environment SBOM creator and also vulnerability scanner. I am running Jake on a Windows 10 VM with Python 3.10 installed. The documentation requires Python 3.6.2 or newer. I installed Jake with pip, but any Python manager will work. To start out, their documentation just says to run jake-help. This doesn't work for me. Currently, they are having issues with it, so instead I'm going to be running python 3-m jake.app. This is the exact same command and has the same output as jake-help would produce, but they are having issues with that command at the moment, so it's currently not usable. So just looking at the help command initially, you can see that there are three subcommands. One performs a scan backed by Nexus lifestyle, the other performs a scan backed by OSS index, and the third generates a CycloneDX software bill of materials. We're going to be checking out the SBOM command first. So if we run this command and add -h at the end, we'll get some information on how to run it. So what we're going to do is we're going to specify the type, which in my case, since I installed this using pip, I'm going to specify pip. Next, I'm going to specify the input file. So for Python, most repositories that are installed with pip do include a requirements.txt file. In my case, I'm going to be using that as our input file. So basically the SBOM generator will read in the requirements and then create an SBOM with information from those requirements. Next, I'm going to be specifying the output. This file can already exist, so you can create it beforehand or overwrite a previously existing file, but you can also create one from scratch with this command. So there's no need to create it beforehand. If we run this command, it should gather all the information from this Git repository's requirements.txt file and then store it in sbom.xml. So if we take a look at that file, we can see that it's a little bit annoying to read. It is only entered in one line, which makes it quite difficult to find anything that's important. But if we down here cat the requirements.txt file, we can see a couple of things that should be in the SBOM. So if we just search up, let's do git plus, we can see that it is found here pretty close to the end. And then if we continue to search, let's do py.yaml, that isn't there. That is very interesting. Let's try the next thing. PyTest. Let's see, PyTest-cov. So the second thing in the list is also not there. Let's continue. So it seems that PyTest async is in fact there. It's found here, version 16, and that checks out. So I wonder why some of them aren't showing up. I really have two hypotheses for the information that we kind of found. The first one is that the SBOM generation in Jake is not that good, which would be a little bit disappointing given that, I mean, it wouldn't be that difficult to find the remaining components. There is a chance that it just didn't find some of the components here, so it didn't include it. So that is also another possibility. The issue I had with trying to figure it out is that most SBOM generators do generate each SBOM slightly differently, and they have different approaches as to how they generate it. So it's very difficult to compare and contrast different generators and to see if this one is in fact getting all the information that it can. If my first hypothesis is correct and it's not gathering the information that it needs and is not that good of a generator, that's very disappointing. If my second hypothesis is correct, then it's a pretty good SBOM generator. It gets all the information that it can physically gather, and that'll give you more information when scanning for vulnerabilities or deciding some next steps in production. The next tool to go over is the scanning tool. So there are two. If we go back to the command that we first typed in, there is IQ and DDT. So I'm only going to be covering DDT in this demo. DDT checks an open source vulnerability exchange, while the IQ command checks your own specific private VEX. The tool has pretty similar implementation for both options, so I'm just going to show you the more common option today. So if we run this command and then DDT, we can see that it comes up with a summary and sees that there is 29 audited dependencies with 2 vulnerabilities found. So after doing a little bit of research into what this scans all currently installed packages on your machine. So it doesn't scan the current directory, it's not scanning this GitHub repository. It is scanning all the installed packages on the machine. This was a little bit strange when I first thought of it. I would suggest to use this when you're developing a program in an environment where you only have the required Python packages installed, because then you can check and ensure that there aren't any known vulnerabilities for the packages that you're using currently. If we look at what the vulnerabilities are showing us, the first one is vulnerability details for pip version 22.1.2. So it has the package that is vulnerable and its version number. It also has the rating, the CVE score, which is 7.8 and a high rating. It has some information on the vulnerability and then some references. So for this first one, it is an issue was discovered in pip because it installs the version with the highest version number, even if the user has intended to obtain a private package from a private index. Basically, this is a known vulnerability and it has been reported that this is intended functionality. So even though some of the vulnerabilities that come up are intended functionality from the creators of each package, it is still important to know because it does state that the user is responsible for using this option securely. The second vulnerability is the same setup. It has the tool name, the version number, some information on the vulnerability, the CVE score, and then any references that are important. So as I said, this functionality is most important when you're developing software in a Python environment using only packages that are installed for the purpose of developing that software. It would be useful just to ensure that you're using the most up-to-date version and you don't have any known vulnerabilities that could affect production. The final scanning option uses your own Nexus lifestyle environment. We can cover this quickly by typing in a very similar command to the DDT command, python3-m jake.app, and then iq-h, so we can get some help information here. So this does require your own Nexus lifestyle web page. It can require a user ID and password if that is necessary to log in to any Nexus lifestyle environment. I'm not going to be covering this here, but it does have the same endgame functionality to the DDT command that we just covered. The main reason why you would want to use this Nexus lifecycle environment instead of the DDT command is just so that you have more control over the VEX that you're using. The DDT uses an open source VEX when you can use your own VEX that might be updated more frequently. That could be very important. Just to summarize, this program can generate SBOMs of Python projects in a couple of different ways. It can scan any currently installed packages and gives you information regarding vulnerabilities present. It also lets you link your own vulnerability exchange when scanning so that you can have more control over the vulnerabilities that it is checking for and possibly update it more frequently. Thank you so much for watching. I hope you learned something about SBOMs. Bye-bye. Thank you for checking out this video. If you really liked it, be sure to check out our other videos right here, and then you can also subscribe right up top here. And again, thank you. Bye-bye.